Okay, we're on. We're on and we're waiting to go. Okay. I have a mask on, so I'll try to shout. It says a chunk of rock of mass 100 kilograms slides down the side of a volcano that slopes up at an angle of 30 degrees to the horizontal. If the rock accelerates at a rate of 4 meters per second, what is the coefficient of sliding friction between the rock and the side of the volcano? Okay? So let's talk about the concepts involved here. All right. This is going to slide. Okay? Now, remember, the downward force, if it's horizontal, me, I'm on the floor, right? My downward force, my weight, equals my upward support, equal and opposite, correct? So my normal is straight up, my weight is straight down. They're equal. If the plane in which I'm standing on is horizontal, 180 degrees, correct? Okay. But this is not the case. Now, if I take a book and I go like this, I have the pen here, right? And I go like this. That pen is going to roll, right? The weight of this pen, of this marker, is always straight down, always, right? But the support force is decreasing as I go like this, correct? And then here, there's no support force. So the weight is not supported at all, so it's in free fall. You with me? Yes or no? So, as the support force decreases, the force that makes this wanting to roll will increase. Correct? Yes? So that's what you're doing here. So let's calculate these three quantities right away. Okay? Yes? Now, we know, use your calculator, we know we're going to use acceleration to gravity is going to be 10. So this is going to be 1,000 newtons. Right? And then this is going to be 100 cosine 30, right? What is it? 100, yeah, the support force. Well, how do we get that? Let's look real quick. This is 30 degrees. SFP. Right? So this is going to be adjacent, right, over hypotenuse. That's cosine, right? So cosine theta equals Fn over Fw, and sine theta is Fp over Fw, right? Yes? So the point is that this that's FW, is going to be 1,000 cosine 30. What is it? 80, close enough? 866 newtons, is that close enough? Big time? Yes?
This is 1,000 cosine 30, right?
100, right? 1,000, sorry,
That's 1,000.
cosine 30, right?
That's 1,000.
I don't understand the question. What is it?
The mass is 1,000.
That's the weight. 866, yeah, that's fine. But I don't know what Umar is on about. What is Umar asking? Umar, what are you asking me?
Is it 100? It's 1,000.
Yes, thank you. I corrected myself, but thank you very much. All right, so then what is 1,000 sine 30? Right? So far so good? Yes? So that's straight down, that weight is going to be, the support force is going to be reduced because it's only 30 degrees. You get it? So, now what? We're given the acceleration. What can we get with the acceleration? We don't know what FF is. We have no idea what the friction is. We know what this is. We don't know what this is. We know that this equals the force of friction over this, but we don't have mu or FF.
So to find it, you have to do.
What is it?
To find it, you have to do mass times Fm. So 100 times 866 to find Fm.
No. In order to find FF, you need to know either the net force or mu and Fn. Now, let me just explain this. I know this. I'm given N, correct? I'm given N, aren't I? A is 4. What's M?
100.
1 is 100. So what's 4
400.
times 100?
400.
So 400 is going to be F net, correct? Hang with me, guys. Hang with me. Do you understand that I know these two things? I know the mass and I know the acceleration, correct? Now I know F net, right? If I know F net, I know that yin and yang thing. What is Darcy talking about, yin and yang thing? What does that even mean? Well, I don't have another color, right? Let me check. I have green, but it's not, green is not user-friendly when it comes to videos, but I'll use it anyway, okay? In other words, I know that this is FP, correct? I know that. It probably looks terrible on screen. I know what FP is. It's 500, right? Yes? Correct? Yes or no? Yes? And I know what the net force is. The net force is 400, correct? So, if FP is 100, I'm sorry, if FP is 500, and the friction I know is this one. That's the friction. And I know that this is 500. I know that that's FP and that's 500 newtons that's making that rock go down. But yet I know there is some force counteracting that 500. Correct? Yes? But I know the net force that's allowing that to go down is 400. So if the net force is 400, and the forward force is 500, what must be dragging it? Well, how much? 100, right? So in other words, I have, this is 500, right? Yes? And there's some force here, which we don't know what it is. We don't know what it is. But we know that when we combine these two vectors, we get 400. So if we have 500 to the left, down, okay, we have some force dragging it. This is friction. And I know the resultant force is 400. I know it is. What must the friction do? I said it before. It must be 100, right? Must be. The friction must be 100. You see that? Yes? If the friction is 100 and Fn is 866, what's 100 divided by 866?
1.15.
What is it?
1.15.
Yeah, times 10 to the 1, dude. Yeah, 0.115. 0.115. Okay? All right. What are the unit labels for that? It's going to be on the test. I'm going to ask you for unit labels for index of friction, coefficient of friction. What are the unit labels? No. Don't look it up. Look, girl. It's force over force, right? So it's newtons divided by newtons. Don't the newtons cancel?
Yes.
It has no unit labels. So if you put something there, it would be wrong. So if you have this, where that's unit labels, you know what you do? Leave it blank. There are no unit labels for coefficient of friction. Are we done? Can we finish? What is it? What is it? This mu is the coefficient of friction. Now you're asking me. The problem's over. I know you had come in late. That's what they told. The problem, Zaytun, was to determine what is the coefficient of friction. That was the whole problem. And in order to do that, I had Fn, but I didn't have Ff. So I could find Ff because I had to work backwards. I know Fp, and I knew the net force because I knew this. So I found the net force 400. So I knew if the net force is 400 that way, 500 for Fp, I must have 100 drag. Correct? All right, stop this. Thank you. Is it still going?